So we've been working on some pretty cerebral stuff. You know what I mean by cerebral? Like you got to use your thinking muscles a lot to do proofs. You got to look at it, you got to look for patterns, you got to try and make connections, you got to try things. You got to psych yourself up because like it doesn't always work out and sometimes you have to try other things. And I promised you guys that mixed in with this we'd do some nice cookie cutter math, and this is what we got today. Okay, law of sines, even though you may not have seen it before, I'm very convinced that if you guys will stick with me today, you'll walk out of here thinking, okay, this isn't that bad. Okay, there are a couple of things. There are a couple of things that you got to know. Other than that, you're just kind of doing the same thing over and over. Before we do this, though, I need to talk about cross products because when I was talking to yesterday's classes and I said, oh, you're just going to have to cross multiply, there were a few people who were not familiar with that term. And I blame that maybe on our online geometry that you guys had a couple years ago, because my geometry students have done cross multiplication so many times this year that they will never forget it for the rest of their lives. But just to make sure, if you have an equation that is a proportion is an equation that has a fraction on both sides. Do y'all know how to solve that? So let's say we got x minus 5 over here and 3 on the bottom and 2x here and say, I don't know, 7 on the bottom. Why not? So just in case you're not comfortable with this, let me remind you that there's this thing called a cross product. It only works on a certain type of equation that's in this format. And basically what you end up doing is you multiply across the equal sign, and that creates a new equation. So I'm going to multiply the 7 by the x minus 5. That goes on one side of my equal sign. And I'm going to multiply the 3 times the 2x, and that goes on the other side of my equal sign. And now I got a nice simple little algebra 1 style equation that I could eventually solve for x, right? Let's do it real quick. That's 7x minus 35 equals to 6x. And I'd probably do minus 7x on both sides to get negative 35 equals negative x, so x equals 35. Is this something that y'all have seen before in some form or another? Yeah. I mean, it's part of the Algebra 1 curriculum, but that's been a while for you guys. Geometry is where we use it a ton because in geometry, when you're dealing with similar figures, this is how you find missing sides in similar figures. So that's usually where people like really get good at it. But I want to make sure you'd seen that before we get into law of sines because we're going to use this. Any questions on cross products before we get into the new stuff? So here's the deal. Let me show you law of sines. Really nice and simple. Law of sines. Okay, first of all, I got to teach you the convention that we use for naming triangles. So go ahead and draw yourself a nice looking generic triangle. It doesn't need to be a right triangle. So this is trigonometry, by the way, but it's trigonometry that does not require a right triangle. So in geometry, and maybe in algebra 2, you guys practice right triangle trigonometry, SOHCAHTOA, but you know that only works if it's a right triangle. Law of sines and eventually law of cosines we'll learn. You can do it with any triangle that you want. You could do it with a right triangle if you wanted to. All right, so we got a triangle. We're going to name the sides a lowercase a, b, and c. The sides would be lowercase a, b, and c. The vertices are going to also be now uppercase a, b, and c, and the vertex a is always across from the side a. So vertex a across from side a. So capital A across from little a. Vertex B, you guessed it, it's going to be across from side B. Vertex C is across from side C. And then we also have angles. Should we use the angles? Let's not bother with the angles. Okay, when I use an uppercase letter in my equations, I'm going to be referring to the angle at that letter. Okay, so when you see uppercase C, I'm talking about this angle right here. When you see lowercase c, I'm talking about the side. Okay, can we all agree on that for right now? I'll tell you, sometimes they use Greek letters for the angles. It's beta is wherever B is and across from side B. Alpha is wherever vertex A is. And then you use gamma for C. Can we just use A, B, and C though? Let's not complicate this thing too much. All right. So knowing that, here's your law of sines. The sine of angle A over little a, so that's the length of the side across from it, happens to be equal to the sine of angle B over side B, which also happens to be equal to the sine of angle C over side C. So in other words, the ratio of the sine of an angle and its opposite side is going to be the same for every angle inside in the triangle. And this is true for all triangles. So how do we use this? We're going to end up writing an equation. Now, we're not going to ever write an equation with 2 equal signs and 3 fractions. We'll write an equation either with those two or with these two or with these two. And then we'll just solve that equation by cross multiplying. You guys got your calculators with you today? Let's get them out. Notice that on this sheet, all of our angles are in degree mode. So let's get ourselves in the appropriate mode here. All right. So I told you all that we would chip away at your homework while we were doing this. So let's go ahead and do that. So why don't we start on number 1? So whatever sheet you're going to do your homework on, feel free to get that out. If it's on a separate place or whatever, or if you want to just start your homework right after the notes, that's fine. We'll skip around. You're going to have to do this. You're not going to have enough room on this handout that I just gave you to do this anyways. Number 1. All right, for this first one, since we're taking notes here, let's go ahead and write out the information they gave us. Now, when you do these on your own, I'll leave it up to you whether you actually want to write this information out or you just want to put it onto your picture. But for this one, we're going to write it out. So that's what it says on my handout for number 1. Is that 8? That's 88, not 8. Sorry. I was going to say 8 degrees is pretty tiny. This is nearly a right triangle. All right, you got that written down? Give me a universal sign if you need a minute here, because I'm about to start the first step. All right, step 1 is you're going to sketch yourself a generic looking triangle. And you're going to name the vertices A, B, and C. It doesn't matter where you put them. I'm going to mix them up a little bit. I'm going A, B, C like this, but you do you. Step 1 is to draw that generic triangle and then place your given information in the correct spots. So this 65 is angle C. It's going to go in the angle at C. This 88 is the angle at B. It's going to go in the angle at B. This 11 is the length of side B. Where's that going to go? Across from angle B. So in my case, on the bottom. Do you guys have a question? So I'd save the side conversations for another time then. So that 11 goes down there. And we're trying to find C. Do you want to call it C or you want to call it X? I'm calling it X. Well, for X, that's what we're solving for. You guys feeling all right so far? So that's step 1. Step one is to sketch and label your triangle. Step two is write your equation. Now, law of sines is always going to be sine of an angle on the side directly across from it. So what you want to do is look through your triangle and see if you can find some pairs of angles and sides across from each other. I see one right there. I see one right here. We're going to use those two pairs to make an equation. So go ahead and set your equation up. They're both going to have sines on the top. And then get the angles and the sides in there. So the X and the 65 went together. Now make sure you get the right thing in the right place. It's angles in the top, sides in the bottom, right? It's easy to get those flipped sometimes. That'll probably be where the most common mistake will be. So here, my angle was 65. That goes inside my sine, and the side was X. I'll put that on the bottom. And for this pair, my angle was 88 and my side was 11. So that's step two. Write your equation. Questions so far? All right. So step one, draw the picture. Step two, write the equation. And these are always going to be sides and angles across from each other. So feel free to, I like to circle them and draw the line. That kind of helps me visually see it. All right. Now all we got to do is cross multiply. So step three is to use cross products. So X times sine 88 would be X sine 88. Oh, I hear buttons clicking on calculators. I don't want to hear any buttons clicking on calculators right now. We do not type anything into the calculator until we get X by itself, okay? The easiest way to end up with a B on this part of the test is to round to a decimal answer in the middle of a problem. Okay, you'll make mistakes and things are gonna go badly for you if you get in the habit of doing that. So at no point do I want you even touching your calculator until you algebraically solve this thing and get X by itself. In other words, don't type 11 sine 65 into a calculator and tell me that that's, 7.2 or something like that, and use that 7.2. Leave it alone. You get to use your calculator one time per problem, and that's it. Okay. The reason is you don't want to round this off to a decimal because that's going to cause errors as you use that number over and over again. If I want to get X by itself, what do I need to do to get rid of it here? Well, divide on both sides, and I would probably not show this step in my work, right? I've released you from showing your algebra steps. But since we're, kind of taking notes here at the same time, let's go ahead and do that. Oh, look, X is by itself. Now that X is by itself, we can type that in the calculator. And then we're done. That's it. Let's go. What do they ask us for? Nearest 10th. That 9 would get bumped up, so we got 10.0 for our final answer. Did they give us units? We should probably include units if they did. Centimeters. That's it. What do you think? Draw a triangle, write the equation, cross multiply and solve. That's it, those 3 steps. Now, there's going to be some that are a little bit trickier to solve, and then I'm going to throw a wrench into things in a minute here. Of course, because that's what we do in math. But can I get you guys to try out number 2 on your own right now? Now, if you don't want to write down all the information, that's fine. You can start by just drawing your generic triangle, putting A, B, and C in there, and put the information directly onto your picture. That's what I usually do to save myself a little bit of time. Try and do as much as you can on your own, but feel free to look up at the screen if you need a hint. Weird rounding in these first two problems. Huh? So I see some of you are even starting to work ahead on number 3. Just give me a thumbs up if you finished number 2 and you got the same answer that I did. All right. I'm going to give you about 30 more seconds before we go on to, we're going to look at number 7 next. If you're finished, go ahead and sketch number 7 out. So this is a little bit different because why? What's different about this one from the last couple we did? We're solving for an angle instead of for a side. And we're solving for an angle and we're using sines. Is anybody anticipating what we're going to need to do at some point? We're going to do that little inverse sine. We're going to have to use an inverse sine in this. An inverse sine kind of throws a bit of a wrench into things, but let's kind of look at the simple case first. So let's go ahead and set up our equation. It's this process is exactly the same. We're going to have an equation with 2 fractions. They're both going to have a sine in the top with an angle in the top, and then some sides on the bottom. We've got x across from 18, and we've got 137 across from 28. Has anybody made the mistake yet where you switched the positions of the angle and the side? Anybody made that mistake yet? You're all going to do it at some point. Get it out of the way early and learn from it. I've done it at least 50 times in my career. All right, so first 2 steps are the same. In fact, the first 3 steps are the same. We're going to still cross multiply here. So 28 times sine x. Well, actually, there's a little bit easier way to do this one. Do you guys want faster or consistent? Both. Can't have it both ways. So I'll show you consistent, and then I'll show you how you can skip a step to get faster. Okay, so consistent, cross multiply. 28 sine x equals 18 sine 137. And then in our next step, we would have to divide by 28. We're trying to get this x by itself, but I need to get rid of the 28 first. So we divide by 28 on both sides. We get sine x equals 18 sine 137 over 28. And there's a pretty straightforward shortcut that gets you straight from there to there without that middle step. But you got to kind of think a little, it's not cross multiplying. It's basically clearing fractions here. If you were to multiply both sides by 18, that would get rid of this, right? But then the 18 would end up multiplied over there. So the fast way is clear your fraction where the x is. Multiply both sides by 18. That would get you straight from here to here, right? If you multiply both sides by 18, you're going to cancel this 18 here, and this side will also have an 18 on it. Okay. So you got to make the decision for yourself. You're just learning it right now. Maybe for now you just stick with cross multiply because it works for all of them, right? It just only costs you one more step some of the time. At any rate, we're down to here. We are not going to type this into our calculator yet because we need to get x by itself. How am I going to get this sign off of there? We'll take an inverse sign. Because the sign inverse sign cancels the sign, right? Usually. Usually is the correct answer. We learned that didn't always happen when we talked about inverse signs in the last chapter. But for this time, we'll let it ride. And that's going to go in a calculator. That whole thing all at once. Don't forget to close your parenthesis after that 137. That's another common source of errors. Wow, these are coming out like rounding to whole numbers pretty frequently, aren't they? Okay. Are we coming up with 26.00 something? You guys feeling okay? I want to throw a couple things in here. So some of you are starting to work on the next problem in the homework, and I love your tenacity, but focus in with me here for a second. You're going to run into a problem at some point on here where it would look just like this, but instead of solving for B, they would want you to solve for A instead. If I had given you this original problem and we were not trying to solve for B, but for A instead, how would we accomplish that? We would do the exact same thing that we did. The thing is, we can't set up a law of sines equation with A because we don't have anything across from it, right? Do you see why we can't use this as our variable here? So we're not going to be able to do that, but we could find the other missing variables because what do we know about these three angles inside of the triangle? They add up to 180. So if they had asked us to find B, we would have set it up just like this. Or sorry, if they'd asked us to find A, we would have found B first, and then we would have finished it up to find A. Can you guys go ahead and figure out what the measure of angle A is right now while we're here? It would be whatever 180 minus 137 minus 26 is. Which is 17. So angle A is 17 degrees. So just look out for that. They may ask you for an angle that you don't know. They may ask you for a side and you might not be able to set it up. Sometimes you've got to solve for something else first and then use that to find the other piece. Okay. All right. Now here comes the wrench. Okay. So far my hope is that you're like, okay, this is kind of nice. Like you can use the same 3 steps to solve any type of problem. And that's absolutely true. Except there's one exception when you're solving for an angle that we got to talk about. Okay, so don't miss this. This will be like the trickiest part of the whole thing today. You guys ready? All right, so there's this thing with sine, an inverse sine in particular. Do you guys remember in degrees? Can someone tell me the range of values that inverse sine will output? The range of negative something to something. What was it? It's negative 90 to 90, right? Negative pi over 2 to pi over 2. You are always only going to get an answer between negative 90 and 90 when you're doing this. Now, since we're dealing with a physical situation, is negative 90 to 0 possible? Really? No, you're not going to see those. But that's problematic because inverse sine is only then going to give you answers for these problems between 0 and 90. Why is that? Why could that potentially be a problem? Isn't it possible for a triangle to have an angle bigger than 90 in it? But inverse sine is never going to give you that angle. Okay, so we have to keep in mind that when we are using inverse sine, anytime we use inverse sine, we have to consider the fact that there might be a second angle that also might work. This is called the ambiguous case. Okay, there might be another one that our calculator just won't tell us, right? Because the calculator is only going to give us that answer between 0 and 90. All right, so here's the thing that you've got to know. Anytime you do an inverse sine, oh, I want to write this down. Let's write a little note on ambiguous case here. This is only when we're solving for angles. You came in just the perfect time. Or angles. Only when we're solving for angles, we have to consider the answer that our calculator gives us. I'm just going to abbreviate that as answer. Or it could potentially be 180 degrees minus whatever that answer is. Okay, and I want us to think about why 180 minus. You don't need this in your notes, but think about our unit circle here. We're dealing with sines, right? Remind me, is sine the x value or is it the y value of the points along our unit circle? Sine is the y value, correct? Can I get you guys to check this out really quick? Eyes up here for a second. If I gave you, let's say, a 40-degree angle, what's 180 minus 40? 140 would be this same angle over here. Its reference angle would also be 40, wouldn't it? What's true about these 2 points? What's true about the y coordinates of those 2 points? They are the same. Okay, so and if you could grab your calculators, I can convince you of this numerically. Type the sine of 40 into your calculator. And then type the sine of 140 into your calculator. They are exactly the same. They're going to be. In fact, any two numbers that add up to 180 are going to have the same value of sine for this very reason. Okay. Now, because of that, we have to, our calculator is only going to give us the smaller of those two numbers, the one that's between 0 and 90. We have to manually go in and check the other one. So when our calculator told us it was 26, that's great. 26 is a valid answer. It's possible there could have been another valid answer. What would the other possible valid answer be for this problem? 26 or what? The supplement, or 180 minus 26, is 154. So our calculator told us 26, but actually 154 is a viable answer, or is it? Tell me why 154 cannot fit into this triangle. We already got a 137 in there. 154 we would have to throw out in this case because it can't fit. Now, sometimes this number will fit, and so you need to include it as a possibility in your answer. Sometimes it won't. All right, so this is the wrench in law of sines. It is step by step by step, but you got to remember, anytime you're solving for an angle, whatever your calculator gives you, that's one possibility, but you also need to stop and say, okay, what's 180 minus that, and see if that would work also. If you can remember to do that one thing, then you're in good shape. So we're going to do a problem where we got to go through the whole process now. Okay. And I'm going to show you, this isn't bad. I can see some of you are like, it seems like a lot for one lesson. You got this. Once you do a few of these problems, you're going to be like, this is no big deal. This is the part of the test that everybody's going to have like 80, 90, 100% on. All right, this is number 13. So the instructions on 13 include also, it's the same as the instructions for 7, except for beware of the ambiguous case. So let's draw our triangle. ABC. Angle A is 23. Little c is 32. A is 19. And we're solving for the measure of angle C. I'm going to call it X for right now. Okay, so I'm going to go through the same 3 steps that I did before, but I like to try and catch this 3 different places, okay? So the first place that I would catch this is right here. As soon as I look at this problem, I know I'm going to have to check at the end. I know I'm going to have to check because why? Well, I know I'm going to have to check because X is an angle. Anytime X is an angle, you're going to have to check this ambiguous case thing. So I'm already kind of trying to keep it in the back of my mind. Now I might forget about it once I get in the heat of battle and I'm doing all the rest of the work for this problem. So there's a couple other places that I'll remind myself as well, but I'm already thinking, oh, ambiguous case. And it might not be a bad idea to get yourself into a habit of like giving yourself a little symbol like, hey, make sure you check this at the end. Okay, but we're just going to do the same thing we just did. Let's set up a law of sines equation. We've got some sides and angles across from each other, so this should go pretty smoothly. X is across from 32, and 23 is across from 19. And your choice, you can either cross multiply or clear fractions. I am going to choose to clear fractions, so I will multiply both sides by 32. We'll get sine x equals 32 sine 23 over 19. If you chose to cross multiply, you had one more step where you cross multiplied and then divided both sides by 19, but we should end up in the same spot. Here's the second place that alarm bells are going off in my head. How do I get this sine off of here? Oh, I need to do an inverse sine, and that's a second reminder. Oh, inverse sine, that's that thing where calculator might give me one answer, but there might be another one. So I'm going to do an inverse sine on both sides of this, which is going to cancel, get x by itself. I'm going to my calculator, typing it in. Oh my gosh, this one has a decimal in it. I'm getting 41.2. Okay, here's the third place that I try and remind myself that 41.2, what? Is that meters or yards or degrees? Oh, degrees, that's an angle. I better check that other one. Okay, so I try and remind myself 3 times. And even though I do that, I will still sometimes forget to check the other angle. So it's either 41.2 or, and then what I usually do is just type minus 180. It's going to give me a negative answer, but it's the answer that the other one would be. So either that or 138.8. I could get that by doing 180 minus 41.2 also. Now, are we going to keep it this time? Is it possible to squeeze a 138.8 degree angle into this triangle? We got enough space, yeah. We would still be able to fill in that space. All right. So, all in all, can you guys tell me how well, before you do, let me just take a step back, broad overview. 3 steps still. Draw the triangle, label all the parts. Step 1. Step 2, set up the equation. Step 3, solve. Either cross multiply or clear your fractions, and sometimes you got to do an inverse. The only thing that gets kind of tricky is that sometimes only when you're solving for an angle, you also have to consider that there could potentially be another angle and check and see if the other angle works. So given all that, can you show me on your thumb meter how comfortable you're feeling with this right now? I was hoping we'd be in that range. So I'm kind of seeing like 50 to 100% right now, and that's making me feel good. Before we move on, we're gonna do one more together, and then you'll have the rest of the time. Before we move on, if I had also asked you to find angle B, which I didn't, if I had also asked you to find angle B, what would you do? What would you tell me? Could you do it? Question? Oh, this is this. I was hoping you'd ask this question. Keep going. If there are two options for the angles, then would there be two options for the other angle also? There'd have to be. Yes. Awesome. Congratulations. You won the Ask the Great Question prize for that one. There's got to be, right? So from this point, if I asked you to find angle B, we are now actually considering two different triangles. Could I get you guys underneath to sketch these two triangles for me? And I'll tell you what, if you'll do this for me, we'll make this the last example. Okay. And then you'll have the rest of the time to work and lower your homework assignment for the weekend. They both have A, B, and C in them. They both have a 23 and a 32 and a 19. But the third angle is different in these two. One of them's 41.2 and one of them's 138.8. So yeah, so we're gonna yeah, they add up to 180. So we'll just do 180 minus 23 minus 41.2. That'll get us one of them. So the 115.8. Now, when you're giving these multiple answers, make sure that you kind of line them up with the original ones, because these would go together, right? We can't mix and match here. And then if we did that same thing with our other angle, 138.8, get 18.2. All right. And go ahead and write those in your two triangles. And then one last thing, and then we'll be done. Last thing, you ready? Could you also find for me two answers for side B? Now this is going to take a little bit longer. All right, this is going to take a little bit longer. But you got it. How are we going to do that? We're going to have to do law of sines again to solve for those two sides. And we're going to have to do it twice. Now it's going to look very similar to itself, but we're going to have to do it twice. So I'm going to do law of sines for this triangle. And when I do this, when I have to do this, and you are going to have a few on your homework where you will have to do this. Oh, I lied. We need to go over one more question. We got to do one more together, but it's from the homework and it'll be the fastest one of all. When I do this and I'm solving for B, I'm going to have to use and one of them I'm going to have to use the 115.8 and the B, and the other one I'm going to use the 18.2 across from the B. Now, in both of them, I've got options for what I put in the other fraction, but what would be the better option to put in the other fraction? I would personally, I would stick with the 23 and the 19 because they came from the original problem and it's going to be consistent for both triangles. So I will go with 23 and 19 for these two. Now this seems like you're going to have to do a lot of work, but you're going to figure out pretty quickly when you've got to do this twice, You're just doing the same thing twice with different numbers. So once you solve this and type it into your calculator, all you're going to do is go back and redo that same thing, but replace the 115.8 with an 18.2. So you guys look for ways to make this a little easier. There are a couple shortcuts you can do. All right, these are going to be the problems that you're going to love to hate. Or hate to love. Or maybe just hate. They're the tedious ones. I told you guys this was going to be the last example, but I misspoke because I forgot that there is a silver lining in all this. Yeah. Well, it'll be good. You'll be happy about this one. So the reason we did this is extra work for number 13, but if you look down at 19, 20, 21, 22, that's what they're asking. When they say solve each triangle, they're saying find all the missing pieces. And this is as bad as it gets because we had two possibilities. Now, we kind of already did this with number 7 because remember with number 7, there wasn't a second possibility, right? So we wouldn't have to do each of these things twice. We just have to do it once. Okay, but there's good news because for every one that you've got to do where you've got to do double the work, you're going to have one where you only have to do a fraction of the work. And that's the piece that I had forgotten about. We need to go over that. You guys want to see that, right? Like the easy one, the one where like you finish the problem after like 25% of the work of this one. You don't want to see that? Yep, you want to see it. Trust me, you want to see it. We're going to do 14 together and then we'll be done. And it's going to go quick. This is the silver lining part of the ambiguous case. Oh, yeah, this is going to make you so happy. A, B, C. We got 65. B is 24. C is 5. We're solving. Ooh, this is weird. It's one of those weird ones. They want us to find A, don't they? So I'm not putting an X in A because we can't solve for A. It's one of those ones where we're going to have to solve for something else first and then use it to find A. So we're going to solve for B instead. We can't solve for A because we don't have any information across from it. You guys see why we can't solve for A? All right, so set me up an equation. Go ahead and put an X where that B is and set me up a sine equation. In fact, I'm just going to have you guys go ahead and see how far you can get with this one on your own. You're going to get to a certain point where something's going to stump you a little bit. Or maybe give you one of those aha moments. They're so fun in math. You found it. Somebody found it. I'm starting to hear it. There it is. You did it right. Keep going. You'll know when you get there. You're gonna need your calculator. Yes. It's all right. It's okay. It's okay. Oh. Oh, that's not good. Double check. Make sure you type it in right. Do you forget your parenthesis? So we've done everything. We hit enter and we get this domain error. Congratulations, we're done with this problem. So this one's finished. So and our answer is no such triangle. Now, this is going way back, and again, your geometry experience may have varied, but it is possible to give information that just it's not possible to build a triangle out of it. If we were to actually draw this thing to scale, this 24 would be roughly 5 times as big as this, right? So I'm going to use one of these units to represent a 5. So this is my 24, a little bit shorter than 25, right? 65-degree angle is going to be shooting off at about this angle. Now, I don't know how long this side is right here, but this side right here is only 5 long. So can I make this side ever, is this side ever going to meet up with this side? Answer is no. So it is physically impossible to build a triangle to the specifications that they've given us. Okay. So for every one of those ones where we got to do double the work, we're going to have one of these ones where we get to here and we're like, nope, we're good. Can't do that. Why did my calculator say domain error? Oh, I love that you guys are thinking about domains and range. That's awesome. Good for you. I'm just going to type in 24 sine 65 over 5. That's what we put into our inverse sine, correct? Why am I not allowed to take the inverse sine of 4.3? Right? It's bigger than 1. Inverse sine, sine's only ever going to give us an answer between -1 and 1, unless we start stretching it or shifting it. So that makes sense that it was a domain error. We're trying to do the inverse of sine of something that's way too big to take an inverse sine of. So numerically, that's why we get that also. So you're going to get, I'll tell you how many you're going to get. I don't want to spoil it for you, so I'm going to unplug my screen here. Spoiler alert. Stop my video too.